So last time we are discussing about electric potential energy and how the electric force became a conservative force uh, based on the following based on the many cases where cases as uniform yung electric force mo or yung electric force mo is dependent on position just like Coulomb's law, and by that we can conclude nga yung electric force mo is really a conservative force, and we can actually write the work done by any electric force as a negative change of the potential energy or the electric potential energy for this case. So f- so this time we will now tackle about another property of your electrical charge system, which is called the electric potential. So by definition, electric potential, or simply potential, is the potential energy per unit charge and denoted as letter V. So the capital letter V is called the potential or the electric potential. So this means that the electric potential is related to electric potential energy based on this expression. Okay, so because of this expression, the SI unit of your voltage or your potential is called the volt actually, and your U is has an SI unit of uh, energy of joules, and your Q sub naught is coulomb. So therefore, 1 volt is equal to 1 joules per coulomb. And since your electric potential energy are both scalars, so just like your charge also, then therefore your V is also a scalar quantity. So we will not deal anymore here with component method, the I hat J hat. We will not deal with that. That is only for electric force at saka for electric field. So here we will just straightforward lang yung calculation niya kasi yung potential mo is actually a scalar quantity. So because of this relationship, you already know that your U, I mean your U is actually equal to the work, diba? Work is equal to that. So therefore, if you divide both sides by say Q sub naught, okay, so the work done by the electric force is just equal to the voltage. And we know that from the fact that the work as the charge move from A to B is equal to, we have here the UA minus UB, then divide both sides by Q sub naught. So we have here UA over Q sub naught minus UB over Q sub naught. And by definition of your potential, this is the potential at point A minus the potential at point B. So that is why we have this expression as you can see here. Okay, so this is actually called the potential difference between points A and B, or potential of A with respect to B. So again, just like electric potential energy, it is very useless or it is very ambiguous to say potential at point A, because we have to choose a reference point because we are dealing with difference, not only for a specific point. So because it is connected to the electric potential. Okay, so again, potential difference should not be confused with the potential energy, because again, even though they are like interconnected by this expression of V is equal to potential energy per unit charge, the potential is actually the intrinsic property of your charge. So just like of your source charge, just like your electric field, diba? If you have an electric field placed in a space, if you have an electric charge placed in space, so automatically it gives us the electric field and electric potential, because these two variables are basically intrinsic properties among source charge. However, for the potential energy, it's like an electric force. You need somewhat like a test charge or another charge para that quantity will coexist with that quantity, like with that variable. For example, if na ako'y electric field, of course, which is intrinsic property of source charge, if naa ko magbutang ko og another test charge, ay mabutang ko test charge, then that means nga maka-exert siya og force, then na electric force nga na involved. Okay? So same lang gyapon sa electric potential energy. If I have a source charge, so it will create a potential at any point in space, and if you have another test charge moving along the same space as of that of your source charge, it will also create a potential energy. So na siya another variable due to that charge system. So again, yung potential mo is actually the characteristic of the field, meaning that it is independent of any test charge. Okay? So basically intrinsic property lang siya ng yung test charge mo, ay yung source charge mo. Okay? So to find the potential energy, or potential, I mean not potential energy, due to a single point charge, we know that U is actually equal to 1 over 4 pi epsilon sub naught. So for 2 charge system, 'di ba, mao man iyahang a potential energy with respect to infinity, 'di ba? So we have to divide both sides by q sub naught to find the potential, which is equal to this relationship. So ito yung as you can see, nawala ng q sub naught because this quantity is again independent of any test charge placed on the field. So intrinsic property lang siya ng source charge mo na q. Okay? So where r again is the distance from point charge q to the point at which the potential is evaluated. So usually ito yung tinatawag natin na field point, pero this one is, we will not talk this one out about field point. Ito yung where potential is evaluated lang. Okay? Then here, just like what we did sa u, remember that this is based on infinity, yung reference point natin, diba? Because your u approaches to 0 if your reference point is infinity. So we will not deal about the change of your potential. So because it is basically u minus u of infinity, which is equal to 0 lang. Okay? So at here, o u of r I mean, for here kasi, so since v is dependent with u, just like the definition of your u, your v must also be dependent on the what we called as the reference point. Okay? So again, if wala gi na specify kung anong reference point sa usa ka problem, you have to assume nga yung reference point natin is at infinity. So if you have to get the potential of a single point charge at infinity, you can see that your v is inversely proportional to the distance. So when r goes to infinity, meaning kung saan natin i-evaluate yung potential natin at infinity, so v goes to 0, just like the electric potential energy. So therefore, dapat kailangan siya og reference point, which is convenient, that can be placed at infinity. Okay? So if q is positive, as you can see here, straightforward kasi yung calculation ng electric potential natin. Okay, so meaning that if q is positive, then of course positive din yung potential na mapoproduce niya. Okay, yung maproduce anywhere in space must be positive. So just like what you did in experiment number 1, diba? So makita ninyo kung mabutang mo og positive q in the simulation space, you already know that if inyo i-calculate ang mga potential anywhere in space, you can see that it is positive. Okay? But if q naman is negative, then it produces negative potential everywhere, which is makita lang din nyo sa sa katong inyong na-observe sa inyong simulation, diba? Katong sa experiment 1 na to, which is again independent of the test charge. Now, same lang din ito na if q is positive, meaning kung magkalayo ka sa imuhang source charge, since your v is proportional to 1 over r, kung magkalayo ka sa imong source charge, what will happen is magkagamay pud ang imuhang potential, di ba? But for negative, bali siya. So meaning that since na ako'y negative, di ba? Kung magkaduol ta niya in magnitude, mudagko siya, di ba? So we have negative, say 200 volts, for example kana. But kung magkalayo ta, what will happen is magka negative 1 volts, negative like 0.5 volts. So these are basically in magnitude, kung ato lang i-neglect ang negative, these are basically less than with the 200. So meaning that your V is inversely proportional to 1 over R, diba? So kung magkaduol ka sa imong negative source charge, it will increases. But remember, the potential nga ma-produce ni negative source charge are all negative everywhere. So with respect sa atong Cartesian coordinate system, your negative 0.5 is actually greater than negative 200. Diba? Kung if we account na the negative 1, so kung tanan nato siyang coordinate system, na yung negative 200 is less than the negative 0.5, which means that kung magkaduol ka sa imuhang negative test charge, magkagamay ang iyahang electric field potential based on the solely on the negative sign. Okay? Pero this will not violate to the fact nga V is inversely proportional to 1 over R. This is just based on infinity. Okay? So yeah, based lang siya sa infinity natin. So if you have many collection of source charges, so just like what we did sa electric field, we just have to calculate. Okay, i-calculate nyo lang yung summation ng Qi over Ri. Then yeah, yun lang. You don't have to deal anymore with component method, yung mga vector quantities, yung mga yung I hat, J hat. So we will not deal anymore. So straightforward lang yung calculation mo. So if your Qi is negative, then put your magnitude of your charge, the value of the charge simply as negative. If positive naman, you just put this as negative. Okay, so straightforward lang talaga yung potential. Yun yung pinaka like easiest nga task natin for electric potential. Okay, so if there is a continuous charge distribution naman, so again, you will just same gyapon sa electric field, we will just get the integral of the small contribution of your dq divided by r. So yung dq mo is nag-exert siya ng nagpo-produce siya ng potential at point say something here, tapos na ako'y continuous charge, so magkuha lang ko og gamay nga dq. So at point say here, gusto na ako ng potential at point p, so it will produce exactly dv, diba? So you just have to integrate para alam mo yung mga mga contribution ng each of the infinitesimally small na charges inside the continuous distribution of charge. Okay, so you just have to deal with this one. Then next, it is better to understand what is the relationship of two intrinsic property of a source charge, the voltage, the potential, at saka ni electric field. So basically, the relationship between the potential at saka ni electric field is given by this equation, which comes from the fact that remember your work A to B is equal divided by Q sub naught is equal to, we have the integral of say f dot dl, then we have here Q sub naught, diba? So from point A to point B. So your work done by the electric force, assuming that we have a test charge but not necessarily na yung E mo is constant, so we can take Q sub naught outside. So diba yung F mo is actually equal to Q sub naught E, assuming that your E is not constant, so we can take that outside divided by Q sub naught. So cancel this out, so what's left is basically this one, diba? So sorry. So dapat kasi since VA minus VB ito, okay, so I think hindi ko na account yung negative change of your potential. So can I erase this one? Okay, so here kasi negative dapat siya because of the fact nga may negative change of potential tayo, diba? So we have here work, the work from A to B is equal to Q sub naught, which is equal to the UA minus UB over Q sub naught, which is equal to VA minus VB. Now yung work A to B mo is actually negative, di ba? So parang a negative change of your potential divided by Q sub naught, which is equal to, ano yun? You have here the negative. So yung negative change of U mo is actually the change of your potential, di ba? So you have the negative change of your potential, kasi yung U dito kasi is actually hindi siya change, so meaning that your reference point here is at infinity. So we have a negative change of potential, so we have this one, then still equal to this one, diba? So we have VA minus VB, which is equal to what is the sign of that? So kani siya. Okay, so kasi yung work A to B over Q sub naught E mo is kani, which is equal to this one. So we have integral of E dot dl. So from A to B, then divide both sides by negative. So what's left is we have an expression like this. Delta V is equal to VB. So ibali lang nato is VA. Tapos the other one becomes negative A to B E dot dl. Or pwede na po niyo i-change ang limits of integration para mawala sa negative 3. Or you can say 289 ano lang siya. Okay, so we have this expression. Okay, so this is very important in using Gauss's application of Gauss's law in electric potential. Okay, this is very important. So again, so how can we deal with like what is the quantity of your potential as we moved away from a source charge which are negative or positive? Okay, so moving with the direction of electric field means moving in the direction of decreasing V. Okay, so as you can see here, if magpa-move ka padulong in the direction of your electric field, you are moving in the direction of decreasing potential. Pero once nga mo against ka sa direction sa electric field, you are moving in the direction of the increasing potential. So just like what we did here, so if na kay positive charge, if you move together with the electric field, the V decreases. Okay, you move kuan man together with the electric field, diba? So but if you move against the electric field, kay dito man imong electric field, then dili ka mo move. So as you move against the electric field, the potential increases. Sorry about that. Sa negative pod same lang gyapon. If you move kay di ba iyahang electric field lines is sync man niya, radially inward man, di ba? So if you move outward, so meaning you are against with the electric field, kasi yung electric field niya is padulong dari nya, mo-move ka pahawa, so di kumuhawa ka sa imuhang negative charge, then your potential increases. But if you move together with the electric field of the produced by a negative charge, then this will decreases your potential. Okay, so as stated here na so do not be confused with this one. Okay, so we just have to internalize that one. Okay, so let's answer this one. So that's the definition of your electric potential. Okay, so parang characteristic lang siya ng field in terms of energy. So how much energy if I put something like potential, so diba if na ako'y positive test charge, so na ako'y kuan dira electric field, so this electric field is actually associated with other energy, diba? So if I put a test charge here, say Q sub naught, so the potential will actually measure what is the potential energy of this Q sub naught if naa siya diri. Okay, so this is very important kasi it is very very interesting to find first the characteristic of the field before going into the field. Murag ka ng kuan ba, dapat ready sa ka before musulod ka sa war. Okay, so you have to understand first the electric charge. So you have to understand its electric field, its electric potential, which are intrinsic property niya, di ba? So yeah, that's the electric potential. So let's move on to this problem. So an electric dipole consists of 2 point charges. We have a positive 12 nanocoulomb, then a negative 12 nanocoulomb, which is placed 10 centimeter apart. Okay. Compute the potentials at points A, B, and C. So the potential at A, so assuming that the reference point is at infinity, so we have here V at infinity is equal to 0. So this is our reference point. So since wala gina-specify niya, then it is understood nga ito yung reference point mo. Okay? So the potential at point A is equal to, so straightforward lang, so we have 1 over 4 pi, then we have summation of Qi over Ri, then we can extend this one to 1 over 4 pi epsilon sub naught, then we have two charges involved naman, so Q2 ay Q1 R1 plus Q2 R2. So we have here 1 over 4 pi epsilon sub naught, then your Q1 is actually the 12 nanocoulomb or 12 times 10 to the negative 9 coulomb divided by the distance. So yung distance mo between A to B is actually, A to Q1 is actually 6 centimeter, or in meters that is 0.06 meter. Okay? So then plus the the Q2, which is equal to negative 12, so you just have to put negative 12 sa Q2 mo, so we have negative 12 times 10 to the negative 9 coulomb, tapos divided by the distance from point A to point B, which is 4 centimeter, or that is 0.04 centimeter. So sorry kaayo kung hinadjud kay akong laptop, so I'm so sorry about that. So this is just so saddening, okay? Heartbreaking. Okay, so it, because it will actually, slow the the lecture series that we had. Okay, so I don't know what's the problem of this one, but just bear with this one. So I cannot write anymore because of the the whirling rainbow here. Okay, so we are done. So that is 0.06 plus negative 12 times 10 to the negative 9 coulomb divided by 0.04. So we have to calculate VA. So what is your VA? So the 1 over 4 pi epsilon sub naught is just 9 times 10 to the 9. So we have here 9 times 10 to the 9. So you can calculate that one if you have a calculator in your side. Okay. 9, then we have 0.06, then we have minus okay, so 12 times 10 to the negative 9, then we have 0.04. So what is the potential at point A? That is equal to negative 1 times 10 to the negative 7. So just just kanang check this one if this is correct. So negative yung potential niya kasi you are moving towards the negative, mas duol man siya compare sa positive charge, meaning mas duol siya sa negative source charge, therefore your potential at point A must be negative. Okay, so I think this is negative, so I will just ako lang siyang i-check ha, kadjut lang. Okay, kaya basig kung ano punta mo wrong. So sorry about the noises ha, kay sa unta di man na ito makontrol ng mga mga ito dari mga tao. Oh, it is negative 900. So what is happening? So this is negative 900. I don't know what is So this negative 900 volts, which is still equal to the fact na mas duol man siya sa negative na source charge. Okay? So how about your VB? So your potential at B is here na siya diri. So same lang gihapon, we have 1 over 4 pi epsilon sub naught. Then we have Q1 is equal to 12 times 10 to the negative 9 divided by what is the distance between Q1 to B, which is 4 centimeter. That is equal to 0.04 plus the negative 12 times 10 to the negative 9 coulomb divided by the distance between Q2 at saka ni B. So that is 6 plus 4 plus 4, that is 14 centimeter or 0.14 meter. So how much is that? So we have here 9 times 10 to the 9, then multiply with 12 times 10 to the negative 9. Okay, so we have here, then multiply this one again with the 1 divided by 0.04, then minus the so we have to expect that your potential is positive, diba? Kasi mas dool man siya sa positive. So let's see if positive ba siya. So yes, that is approximately, just check in your calculator ha if sakto ba niya siya, 128.57 volts, which is positive kasi mas dool man siya sa imuhang Q1. How about at point C? So what is the potential at point C? What do you think? So again, same lang gihapon, 1 over 4 pi epsilon sub naught. Then we have the Q1, which is 12 times 10 to the negative 9. Then the distance between Q1 and point C is 13 centimeter, or that is 0.14 meters. Then plus negative 12 times 10 to the negative 9 divided by the distance between Q2 and C is equal to 0.13 again. So this must be 0.13. So as you can see, this is equal to 0 volts. So meaning exactly at the center of an electric dipole, okay? So the potential here is actually 0. So meaning that there is no work done by the field if your charge is moving here. Okay, exactly at the center of the two electric dipoles. So mo nang pasabot sa 0 volts. That is with respect to infinity. Okay? So how about this one? What is the okay, so we still have to find the potential energy. So compute the potential energies associated with a point charge of positive 4 nanocoulomb if it is placed at points A, B, and C. So this is just a straightforward na calculation again, because we know from the fact V is equal to U over Q sub naught. Again, the reference is at infinity, so there's no need for you to put delta U. So for the change, so we have here U at point A is equal to VA tapos the Q sub naught, diba? So the potential at point A is equal to negative 900 volts multiply with the test charge of positive 4 nanocoulomb, or 4 times 10 to the negative 9. So how much is that? So we have 900 times 4 times 10 to the negative 9. So that is equal to 3.6 times 10 to the negative 6 joules. That is in negative. Okay, so how about B? The potential energy at point B. So you already know the potential at point B. So you just have to multiply this one with the test charge. So what is the potential at point B? So that is 1928.57 multiply with 4 times 10 to the negative 9. So how much is that, man? So 1928.57 multiply with 4 times 10 to the negative 9. So that is equal to 7.7 times 10 to the negative 6 joules. So that's how you do it. So you will not anymore use this expression. You have to calculate again the summation of, say, q sub naught r and so on, because you are given with a potential naman at that point. Okay, so you just have to use this expression if you have the the potential na at point. Okay, so you see potential energy at point C is equal to, of course, 0 joules. So there is no work done by the field if your charge is moving across this line exactly in the middle. Okay, so let's move on to sample problem number 2. So a charge Q1, which is equal to 2 microcoulomb, is located at the origin, and a charge Q2, negative 6 microcoulomb, is located at 0.3 meters. So located siya sa y-axis as shown in the figure. Find the potential energy when 3 microcoulomb is placed at point P. So we have to find first, it is best to find first the potential at point P, then we will now deal with potential energy, just like what we did atong sample problem number 1. Okay, so the potential at point P is just equal to 1 over 4 pi epsilon sub naught. Then we can let your 2 microcoulomb as Q1 and negative 6 microcoulomb as your Q2. So Q1 is 2 times 10 to the negative 6 coulomb divided by the distance between 2 microcoulomb to point P is 4 meters. So I can put as 4 meters. Plus my Q2 is equal to negative 6 times 10 to the negative 6 coulomb divided by the distance between 6 and point P. So ito yung distance niya. So what is the distance of that? You just have to get the so the R2, just have to get the Pythagorean theorem. Okay, so that is 4 squared plus 3 squared, which is equal to 5. Okay, that is 5 meters. So we have 5 meters here. So diba? Okay, so then calculate. So how much is that, man? So we have okay, so I cannot exactly, you just have to find this one, because I cannot exactly kanang see nga sakto ba yun na akong calculation, okay, or my process. So it's up to you. So we have 2 divided by 4, then minus 6 over 5. So that is negative 0.7. So negative 0.7. So that is negative 0.7. So why do you think na negative 0.7 siya? Why do you think? Okay, because as you can see here that the 6 microcoulomb is greater than the 2 microcoulomb. So mas dako man og charge ang imuhang negative charge compare sa positive. So therefore, if dako, even though mas gamay og mas dako og distance ang imong Q2 kaysa Q1, pero mas 3 times greater man ang imuhang negative 6 microcoulomb. So that is why the answer is, how much is that? Okay, so I'll just, so that is negative 0.7 volts. Okay, so that is the answer. And we have to calculate the potential energy if the 3 microcoulomb is exactly placed at point P. So you already know the potential at point P where the 3 microcoulomb is located. So you just have to multiply the potential at point P is equal to multiply the negative 0.7, multiply this one with the 3 times 10 to the negative 6 coulomb. So how much is that? So that is So that is equal to negative 2.1. So that is negative 2.1 times 10 to the negative 6 joules. So again, negative gap siya. Okay? So yeah. Okay, so let's move on naman sa continuous charge. So by definition, ito yung formula ng ating potential at continuous charge distribution, assuming that yung reference point mo is at infinity, meaning that your V is equal to 0 at infinity at your reference point. Okay? So next, first is we have to find the potential on the axis of a charge ring. So as you can see, merong charge ring ako dito. So just like what we did sa electric field, your ring has a total charge of positive Q and a radius A. Okay, so the axis is exactly located at the center of the ring. So we could let this as positive X, at saka the other naman here, the other here is your negative X, di ba? So that is based on the Cartesian coordinate system. So we have to find the potential at point P. So you have to use this equation to find the potential at point P. So ako naman gibutang diri, so you can follow. So we have K divided by R. So R here is actually a constant naman, just like what we did sa electric field. So anywhere on the ring, you can calculate your R as constant. Okay, so it doesn't matter. So you can take that outside kasi constant si R mo. Yung dq mo is just the total charge on the ring lang, di ba? That is the total charge on the ring, yung dq. So you just have to get the total charge, which is q. So we have to k. So it's just equal to kq over r actually. Pero we need to find the value of r, the distance of our dq padulong sa point P, which can be used using Pythagorean theorem as the square root of, so your r here is actually the square root of x squared plus a squared. Diba? So yeah, so you can have this expression. Now, it is very best if we have to find the potential of the ring charge when your P is goes to very very large compared to the radius of the ring, and see to it nga tanaw na to if it is kanang mo-coincide ba siya sa ato ang prediction nga the ring becomes a point charge. So here I have to get here x squared, so maunang na ako yun ani because I extract x squared from here, and if your A is less than your x, so meaning that A over x is less than 1, so therefore yung a squared x squared mo is actually less than 1, and your V at large distance x, meaning your distance of P mo is equal to kq over x. Okay, so this is actually meaning wala siya og point charge nga na ay total charge q. Okay, so that's it. That's actually the potential. Okay, so how about the potential on the axis of a uniformly charged disk? Okay, so yeah, so this part is we just have to, just like what we did sa electric field, itagpi na to ang ato ang charge disk into a very small ring. Okay, so okay, so wala man gibutang diri ang solution, so I will just ako lang siyang ikuan sa inyo ha. Okay, so here, so your V is actually equal to the integral of, say, k dq over r. But your dq, again, so just like what we did sa atong electric field, is equal to sigma dA. Okay, since you are dealing man with a surface, assuming that yung thickness ng disk mo is very can be neglected. Okay, so we have here sigma, tapos yung dA mo is actually equal to 2 pi r, 2 pi a, kasi a yung radius ng isang ano mo, yung very small disk mo, dA. And this dA will be kanang i-add na to from radius is equal to 0 from the total radius of the disk. So ang a is actually the variable that is changing. Okay, so we have here your dq, so we have k, the integral of sigma dA over r. Then we can compute also your r as a squared plus x squared, as you can see here. So we have here k, so we have the integral, so the r here is not anymore constant, so we cannot take that outside of the integration expression. So we have 2 pi a dA square root of a squared plus x squared. So what's changing here is a, so we have to integrate this one with respect sa a because your x is constant. So constant na siya always nga dili ang distance, di ba? Kung asa pa ka nga ring diha, your x is still constant. Okay, so we have here k, sigma is constant because charge density are always constant in our case. Then we have here a dA, the square root of x squared plus a squared. And then we can calculate this one using integration by changing variable, di ba? So let u is equal to x squared plus a squared. Then your du is actually equal to 2a dA. Then therefore, du over 2 is actually equal to a dA. So we have here v is equal to, how much is that? So we have k sigma 2 pi, then we have here du over 2 is equal to a dA, then we have the square root of u. So the limits of integration is ato lang siyang ibutang at the end of the expression na, okay, where we change the u na into the original expression. Okay, so we have here 2, so the 2 here is wala naman siya, so I can take that, cancel out. So we have pi k sigma, then we have here u to the negative 1/2 plus 1, so that is u to the, is it negative 1/2 plus 1, diba? So negative 1/2 plus 1, that is pi k sigma, then that is u to the 1/2 divided by 1/2. Okay, so changing the expression of u, so we have v is equal to 2 pi k sigma, so 2 comes from the 1/2 below, then u is actually equal to x squared plus a squared. So integrated from the radius equal to 0 padulong sa radius equal to capital letter R. Okay, so we have here 2 pi k sigma, then we have square root of x squared plus r squared minus 0 man imong kuan, imong a here, so meaning x na lang mabilin. So you can actually provide an expression here just like this. Okay, so you can actually do it yourself. So kung magkuha kag x from both terms, so magkuha kag x dere, so magawas ang x diba dere, so x common term, so kung take outside, so na ko yung ani nga expression. So using this expression kasi, so we have to take a look at if the x is very large compared to the radius, kasi we have to take note that it will coincide to our expectation nga yung disk mo is magiging positive charge, magiging a single positive point charge. Okay, so let's see. So if your x greater than r day, the radius of the disk, the total radius, if your x is greater than r, you can see from this expression, okay, that you have like that you have here this is actually a form of a binomial expansion, meaning that if your r over x is less than 1, then this square root of 1 plus r squared over x squared can be equate to a series expansion equal to this one. Okay, So para makita nato ang iyahang expression yun, okay? So we have here 1 plus r squared over x squared raised to 1 half in binomial series that is equal to 1 plus 1 half r squared over x squared plus dot 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 dot. So you can extend this one to infinity. So next is we just have to get the two first terms of the binomial series. Okay, so tanaw na to, okay, because kung padayon pa man ka, that is very small naman kay to mga 3/4 and so on are R4 to the and so on, okay? So yeah, so we just have to get the first two terms, and we have to replace the square root of this one by 1 plus 1 half r squared over x squared. So this will cancel out 1, so what's left is 1 half r squared over x squared, diba? So yeah, so ang ma-left na lang sa expression dito is actually v is equal to 2 pi k sigma, then we have x. So the absolute value is just meaning that it can actually calculate if napunta dali, okay, if your x is negative, meaning lang sa absolute value, but you can actually get that one. Okay, you can actually, this is not anymore kanang necessary because our x here is positive. So we have 1 half r squared over x squared approximately, kasi you have to approximate that one. So we have here v approximately is equal to cancel 2, then we have here cancel na pud si x, so what's left is pi k sigma r squared over x. So how can we get this one into a expression like this para makaingon ta nga potential siya for a single point charge if mulayo ta? So remember that sigma is just equal to the total charge, which is q, divided by the total area, which is pi r squared. So we can put this one as sigma, so we have ang nabili na lang kay kq divided by x because mag-cancel out naman ang pi ug r squared, okay? So meaning it is really our expectation nga mauto gyud siya sa point charge if mapalayo imuhang p, okay? Yes, that's it. So the next example naman is itong line charge mo. Okay, suppose na ako'y line charge. Okay, I have a line charge here that is a positive, okay? A positive line charge nga may charge density of lambda. So you have to find the potential anywhere in space. Okay? So yeah. So what we did here is we just have to find the potential at radius say r. So at distance r here, we already know using the Gauss's law, we can find the expression sa ER mo. Okay? So we cannot actually use directly this one kasi we can actually calculate the E here without calculating the, the V, because it is very hard to find R. Okay, if we use this one, so we just have to use the relationship ng ani. So V is equal to delta V is equal to the negative change of your E dot dl. Okay, so we can use this one from that is from point A to point B. So now at this point I have to tell you na not all of the reference point at infinity is at convenience here, because since our line of charge extend to infinity, this cannot be true, because if you have to extend also, meaning that if you had to extend also to infinity the line of charge, the potential at infinity is not equal to 0 anymore because of this because of our line charge extending to infinity, okay, which is not correct anymore. So using this expression, we just have to get the potential, say at point, we have to calculate the potential at point R, meaning dito sa surface ng line charge natin to point here. So ito lang yung reference point natin, which is easily be done. Okay? So yeah. So ito yung point charge natin. So let's just calculate that one again. So what is the answer of this one? Okay, so what you're going to do is you have to take note that from the boundary, we have here R to, ito yung line charge, ito yung axis niya, yung axial axis ng ating line of charge. Okay, so ito yung radius na R. Okay, so we know that the electric field of produced by the very long line of charge is equal to, pila ganito, electric field is equal to, pila to, hello, is that equal to, hello, so so nakalimot po ko. So okay, so if we have a line charge, okay, nga na ay say, nga na ay radius say R, then this is a positive line charge, then I have to get the electric field outside para makita na kung electric field. So I have to make a Gaussian surface, which is a Gaussian cylinder because it is symmetric with our line charge. Okay, so the electric field is, this is extending to infinity extending to infinity. So the line charge is pointing outward, yung electric field. Okay, ana siya diha. So walay net flux diri ug diri, so katulad siyang curve. Okay, mao na yung net flux. Okay, so therefore yung electric field using Gauss's law, so we have the flux is equal to the sa to bitaw E dot dA, diba? So which is Q enclosed over epsilon sub naught. So this is only the flux through the curved surface. So the, at specific, like the area of your kaning curved surface, the dA here is actually we can argue that your E is constant at any on the curved surface here, constant siya here. Okay, so can I just put a yellow, constant siya diha. Kani kay zero naman imong kwan diri, imong electric field at this yung flux at this point. So we have E, then we have A. So what is the A of that circle? I mean the curved surface, which is equal to 2 pi RL. So we have the radius R. So radius R ng Gaussian surface mo with respect to the axial line ng ating ng ating line. Okay, so ito yung Gaussian surface mo yung may distance R from the axial axis of your wire. So what is the Q enclosed? So again, the L here is the length of the Gaussian surface. Length of the Gaussian surface. Then the Q enclosed is actually equal to lambda times L over epsilon sub naught. So therefore E, so I would just sa makita namin niyo sa yung solution sa last time. Okay, so that is 2 pi R epsilon sub naught. So this is the electric field. Now we have to find the electric field assuming that your reference point is nasa yung surface. Okay, so we can find that one. So we have the potential B is equal to the potential this is at point, is it point A minus point B, diba? So I will just check. Okay, okay, so it is point B minus point A. So we have here, I will just check. So we have point B, yung point B natin is si Gaussian surface at yung point A is the surface of the line charge. So ito yung point A natin. So yeah, nagkuan na pod gahang. So let's just uh, guys, I'm so sorry about that for a long pause. Paway sa ta, okay? Okay. So napoy advantage ang pagkano pag loading sa laptop kay makapahuway pa ta. Pero anyways, so yeah, so do you understand lang sa akong gipangingon dali? Okay, so kaning mga flux ha is just kani siya is just the review of your Gauss's law katong last time that we, so that is the potential at point B, so that is at point R minus the potential at point say R. Okay, so at the surface of the like the potential at the surface, we can actually put the origin, I mean the reference point is equal to 0 at the surface. Okay, which is actually okay for you to do. Okay, so we have here what is the potential at point R? So we have here E. Okay, so we have here, so we can let our potential at the surface again as 0, okay, because this is our reference point. Okay, so at the surface, so using this equation, so we have here delta V, or V is equal to we have the negative E dot dl. Then we have here we have here negative tapos lambda divided by 2 pi r epsilon sub naught, so that is from r to the small letter r. So how much is that? So that is like the integral from r to small letter r, tapos yung dl mo is actually the displacement from point here to here, which is just dr, so we can let that one as dr. So here we have negative lambda over 2 pi epsilon sub naught, and then what's left is ln of r. Okay, so we have ln of r divided by r, then putting the negative inside, so we have lambda over 2 pi epsilon sub naught ln of r divided by r. Okay, so this is the potential in that surface. Okay, so in this point outside, if the reference point is here. Now, as you can see here, nga hindi natin pwede actually parang i-make the infinity as our reference, kasi as you can see that the potential also goes to infinity at infinity. Okay, so as you can see na if your r is equal to r, the potential is obviously equal to 0 because that is our reference point, because r divided by r here, your potential is 0, diba, which is correct. But when r is equal to infinity, what will happen to this expression? So we have lambda over 2 pi epsilon sub naught ln of r divided by infinity. So what will happen if this is r divided by infinity? So what do you mean by that? So ln of infinity, or ln of like 1 divided by 0, So what do you think? This goes also to infinity. I know, ln of r over infinity, yung r over infinity mo approximately goes to, I mean yung r over infinity mo approximately goes to 0, 'di ba? So meaning that ln of 0 is actually equal to infinity. So this approaches to 0 and ln of 0 goes to infinity. So this reference point is not anymore true. So mas better if you put the reference point at r is equal to r, which actually coincide with our expression of our potential. So ito lang yung ano niya, yung parang um, parang exception na yung potential mo is not at infinity kasi you have to make your charge distribution kasi in like anong tawag dito, parang localize. What do you mean by localize? Meaning that if hindi localize yung charge distribution mo, meaning if my extension to infinity, we cannot use this reference point. Okay? We cannot use this one anymore. But if localized siya, for example, na nandito lang siya sa isang point at hindi siya na-extend to infinity, then you can use actually this reference point. Okay? So yeah, that's it. That's actually the reason why dapat localize ang imuhang electric charge distribution. Okay? So now we will deal with electric potential using Gauss's law. Okay, so this is like an application of your Gauss's law lang, 'di ba? So basically, if you are watching my lecture video sa Gauss's law, you are going to calculate first the electric field using Gauss's law, and then using the expression we had, the delta V is equal to the negative E dot dl, then you can find the potential at any point on the continuous charge distribution. Okay? So for example, if na ako'y a spherical shell and a radius r, so we have to find the electric field, electric potential inside at saka outside. So inside is what you're going to do kasi, so since localize yung charge distribution mo dito, yung reference point mo can be used as this one. Okay, so meaning at infinity, yung yung potential mo is equal to 0, diba? So we can the outside the spherical shell is actually, we have to find the potential, say at infinity, padulong at this point, meaning at point RP with respect sa imuhang center sa imuhang circle. So we will calculate the potential here, okay, with respect to infinity. Okay, so we have to find the infinite potential difference between these two two variables. So we have V is equal to, the change of V is actually equal to negative infinity to RP. So you have KQ over R squared dr. So your dr again is pointing in the same direction as your electric field. So we already know the electric field outside is KQ R squared, diba? Outside, right? So we have here, ako lang siyang ibutang diri, okay? So I would just put it here. So diba naakay sphere nga naay radius r. Okay? So first we need to find the electric field outside. We already know that the electric field outside is equal to KQ over R squared, assuming that yung total charge ng spherical shell mo is Q, and that is in the R hat direction. How about the inside? So inside, since this is a conducting spherical shell, the electric field inside is obviously 0. So we have to find the potential outside at saka inside. Okay, so first, we will deal with outside muna kasi yung reference point natin is from infinity Tapos suppose ito yung Gaussian surface natin with say radius r. So based on this one, so we have to find the potential at point here, at point infinity padulong diri, 'di ba? So kung ano tong potential at that point, so this is actually the this potential here can actually be like represented by the potential outside of the of the charge distribution. Okay, so that's why we can use this equation. Okay. Okay, so I'm so sorry about that. So yeah, we have to find the potential here at point outside. So we have here potential difference is equal to the potential from from point R to the potential at infinity, which is equal to, so this is 0. So basically what's left is your VR. So that is equal to the negative of the infinity to say R, yung distance here ng Gaussian surface mo from the origin, that is your E dot dl. We have KQ over R squared R hat dot dr R hat. So dr means nga yung dr mo is in the same direction as your, yung R. Okay, kasi yung dr mo is paana, di ba diri? Okay. So yeah, you already know the concept. So we have negative infinity to R kq over R squared dr. So integrate, that is like equal to kq, then we have negative 1 over R negative, that is infinity to R, so that is equal to kq over R. So you just replace R with R, and infinity, 1 over infinity is equal to 0. So what's left is this one. So do not be confused with R and R here. Okay, so they are basically not the same, pero yeah, sumoon nang ginakuha nila diri as RP kay kasi pa dili malibog sa R ug R, but they are actually the same. Okay, so this is the potential at outside this spherical shell. How about inside? So sa inside kasi we have two boundaries from infinity, tsaka we have to stop here at point R, at saka from point R padulong sa imuhang Gaussian surface nga say na ay radius nga say na pud R, di ba? So natay duha ka boundaries ato ang potential. So we cannot just directly calculate infinity to R ditso inside, because it will just, it will actually have the same kanang result with the potential outside, so which is incorrect, because we have a boundary between two points. So from infinity to radius R the surface, tapos the radius R padulong sa imong Gaussian surface, and that's how you deal with the potential energy inside. The potential inside. Okay, so we have the potential inside is just equal to the negative infinity to say R, ito yung outside nga na electric field, plus the negative of the R padulong sa imong Gaussian surface E dot dl. Okay, so as you can see here. Now, remember, itong electric field na ito is actually the outside one kasi yung electric field here is actually the outside expression. Now, the electric field inside is actually from R to R, so which we will use inside the spherical shell. So this one is actually equal to 0 because the electric field is actually equal to 0. Diba? So what's left is actually equal to, say, negative, then we have infinity to R. So same lang din ng expression here, but yung R mo is now a capital letter R. So we have here KQ over R squared dr. Then we have here KQ times 1 over R. That is from infinity to the capital letter R, which is equal to KQ over R. Now remember, even though the electric field is 0 inside, it does not necessarily mean nga ang potential inside is 0, but it is constant, which is equal to the potential on the surface. So meaning, kung tanaw nimo ang imuhang graph between the potential of the distance, so may boundary siya nga when R is equal to R, so inside the potential is just constant until it will decrease in this value 1 over R. Okay, so yeah, that's how you deal with application of Gauss's law using potential. Okay, so next is we have to, again, sample problems sa punta, we have to calculate the potential at point P on the y-axis at distance A from the origin. So with a uniform line charge density of Q over L. So we have to find the potential here. So again, straightforward lang siya. Dili siya necessary na magkuha pa tag components, kuha pa tag theta, but simply just put all of the values that are necessary for calculating the potential. So again, localize man yung charge distribution mo here. So meaning that it does not extend to infinity. So we can let our reference point to be at this infinity. Okay? So we will not deal with a potential difference anymore. So I will just put it here. Excuse me. Okay, so I will just put it here lang. Okay, this is the line charge. Okay, so this is the point P, a distance A from the origin. Tsaka next is we have lambda. Okay, lambda. So meron siyang lambda is equal to Q over L. Now, just like what we did sa atuang electric field, we have to find a small dq here sa atuang line charge. Then after that, we have to let the distance between the dq na imong gi-choose to the origin as x, okay? And then the distance between P to the dq is basically your R. So imo siyang lantawon, your V is actually equal to K, the integral of dq over R. So the R is actually the square root of x squared plus a squared by Pythagorean theorem, diba? So but the dq, since we are given with lambda here, we can just write this one as lambda dl, a small line charge here, but that is actually on the x-axis, so we can let that one as lambda dx. Okay, so we have k lambda, we can take that outside, dx is equal to the square root of x squared plus a squared. So you can actually get this integration by using the table of integral that I have been posted last week about the electric field in continuous charge distribution, diba? So what is the value of this one? So that is actually equal to, we have k lambda, then ln, we have here x plus the square root of x squared plus a squared. So ito yung ano niya, yung counterpart ng expression nito. So integrated from, of course, from 0, yung other side ng line charge mo padulong sa imuhang distance, which is naa siya length nga L. So ito yung L at saka ito yung 0 mo. So that is from 0 to L. So we have to integrate from 0 to L. So your V is actually equal to K lambda ln. So we have to replace x as L. So L plus the square root of L squared plus A squared. Then we have to minus ln of 0 plus 0 squared. So what's left here is just A. So the potential at point P with respect to infinity is equal to K lambda ln. So we can, using the property of your natural logarithm, so we have L squared plus A squared divided by A. So we can leave at that one, pero atong lambda is Q over L man. So we can just replace also your lambda as KQ over L. Then we have ln L plus the square root of L squared plus A squared divided by A. So this is the potential at point P with respect to infinity. Okay? So how about this one? Yeah. An insulating solid sphere of radius r, insulating has a uniform positive volume charge density rho, so I forgot the rho, and a total charge q. Find the potential at a point outside the sphere and find the potential inside the sphere. So this is actually using Gauss's law. So we can calculate that one using Gauss's law. Okay? So I will just give you how I will just calculate this one step by step, meaning from the start kung ano itong electric field muna outside, tapos kung ano itong electric field inside, then kung ano itong electric field. So just like what we did sa ato ang like okay, so just like what we did is we just have to, okay, so I would just put something here. Okay, so mag-insert sa ko blank page, okay, para makita nato ang kan. Okay, so diba naatay circle nga naay volume charge density na uniform, okay, with radius r. So this is a solid insulating sphere, so we have to find the electric field first inside at saka the electric field first outside. So the total charge of the sphere is equal to Q. So Q yung total charge niya, so we have here Q. So first we have to find the electric field outside. So it's bet kasi dali ra kay siya. Okay, so you have to draw the Gaussian surface outside, which is a sphere because it is symmetric with the charge distribution. So the electric field outside of the insulating shell solid is equal to KQ. Ako lang dito over R squared R hat. But for the inside, so what you will do is just you just have to get the rho over the Q total divided by the total volume is equal to Q enclosed divided by the enclosed volume, diba? So mao man na. So katong pagkuha nimo sa electric field inside, then nakay that dA is just equal to, what is the Q enclosed? So Q enclosed is just equal to this one. So we have that the total volume. So ang Q enclosed nimo is equal to the total volume divided by the total charge divided by the total volume times the enclosed volume. So we can just put it here, V enclosed tapos divided by epsilon sub naught. So the electric field is inside the insulating shell, so with radius say r, so we can take that outside. So then the dA is actually 4 pi r squared. Then the total charge is Q. Ako lang giditso na siya kay because I know that you already knew this one, r cubed. Then I just cancel out 4/3 over pi, 4/3 pi epsilon sub naught. So we have here the electric field inside of the insulating shell is equal to Q over 4 pi epsilon sub naught r cubed. Then we have r. So that is in the direction of r hat. Now how to find the electric field at the electric potential outside at saka inside. So just like what we did sa atoang last sample problem, the reference point is at infinity, which is equal to 0 yung electric potential natin. So electric potential when r is greater than r, so dun muna tayo sa labas ng Gaussian surface. So we have here, so ito yung Gaussian surface natin sa labas. So maasay kuan nga r, so that is from infinity tapos at point here. So this one represent actually the potential outside the insulating shell. So we have here the delta V is equal to the negative, so we have infinity tapos r of the Gaussian surface outside, E outside dot with dl. So the E outside is just equal to kq over r squared. So I can take kq outside. Then we have 1 over r squared dr kasi yung r hat mo at saka dl is in the same direction. So that is from infinity to r. So same lang gyapon ng nakuha nato doon sa sa taas. So that is kq over r. Okay, ito yung potential outside. But how about the potential inside? Okay? So what do you think is the answer? So kay since bounded man yung yung Gaussian surface inside, so we have to tungaon na to tong Gaussian, ato ang integration. So do not just dito nga sigma to r. Okay, so you just have to cut from infinity to the radius r na dako, the surface of the charge distribution, tsaka r to the Gaussian surface na may radius na r. So we have here delta V is equal to the negative infinity to r, so dun sa labas out, that dl minus or plus negative of r to the inside na ni siya, so E inside that dl. So how much is that? So delta V is actually equal to negative infinity to r, so we have kq over r squared dr. Kunang ditson ha. So we have r to r, then the inside is just equal to this one, so we have q r over 4 pi epsilon sub naught r cubed, then we still have dr. So next is this integration is just equal to this one, but the r here is now equal to the capital letter R, so we have kq divided by capital letter R minus, we have here q over 4 pi epsilon sub naught r cubed, so kay constant pa na sila, Then the integral of r is just r squared over 2. So we have r squared over 2 minus r squared divided by 2. So simplifying, we get actually the answer of kq over r minus q r squared. Then we have 8 pi epsilon sub naught r cubed. Then we have here plus q q over 8 pi epsilon sub naught. We have here r. Is it r? Yeah, r. So this can be actually kasi yung k mo dito is 1 over 4 pi epsilon sub naught, di ba? So we can actually combine these two. So that is 1/4 plus 1/8. So we have here, how much is that? So 1/4 plus 1/8 is equal to, so we have 2 plus 1, so we have 3/8. So we have 3 over 8, 3q 8 pi epsilon sub naught r minus q r squared over 8 pi epsilon sub naught r cubed. So you can leave your answer like this, or you can, para lindot siya lang tawon, so you can put your answer as this one. So we have q over 8 pi epsilon sub naught r multiply with 3 minus r squared over r cubed. Okay, so it's just, I mean r, this is r squared kasi yung r mo is na naman sa usa gawas. Okay, so kung lantawon ni nato, makita nato nga kung atong ikuan ang v o r sa ato ang spherical na insulating shell na may radius na boundary r. So inside is just mura siya og kanang mo decrease ay mo increase siya in r. So how to do that one? So mo increase siya at r. So mo siya ang ana siya basta mo increase na siya, then until such time nga mo decrease din siya paana. Okay? I think that's the point of the studying potential. Okay? So imuhang kuan biha kay maan na siya diri, imuhang r ay imuhang potential outside. So yeah, so